Okay, hey everyone, welcome to Unit 6, working with radical expressions and radical functions. That'll be the next family of functions that we'll be dealing with here in this upcoming unit. Um, Sorry I can't be there with you guys, but I'll do the best I can right now with these next several lessons here to guide you through this process and try and make it as painless as possible here. Okay? So, we've all taken square roots before, right? If I ask you what the square root of 25 or the square root of 36 is, square root of 12, you guys could either give me the integer answer or you can give me the simplified answer, right? Think back to when we had those really, really great square roots, like the square root of 36, or those really great square roots of the square root of 7, but those really not so much fun ones as square root of 7, or I'm sorry, not square root of 7, but square root of 27, where we had to simplify the square roots. We're going to be doing a little bit of that again here in this unit. Okay? But here's the good news about what we're doing here in this unit. We're going to focus primarily on square roots, but we're also going to explore other roots besides square roots. For example, when you look at problem number 1, right here, we're going to be looking at other roots such as cube roots or fourth roots and learn about how we can figure those ones out. So pretty much our objective here in 6-1 is we're going to try and find nth roots. Any type of root, whether it's a third root, a fourth root, a fifth root, whichever ones we can find here. Okay, now there's a couple of rules to keep in mind here about roots. Okay, number one, if we are taking a root, well, first of all, let's just set the groundwork here. Suppose we have a number raised to a power equal to another number. So, for example, what if I told you that 5 squared is equal to 25? True, right? Then what must be true is that this a that's right here, this 5, is a square root, because we have that 2 right there. It's a square root of b of 25. Okay, so that just lays the foundation for other types of roots that we'll be looking at here. For example, suppose we know that 2 to the third power, 2 to the third power, 2 times 2 times 2, isn't that 8? So then what must be true here? That we can say that 2 is not a third root, but we call it a cube root of b. Let's do one more. Suppose we looked at, say, I don't know, let's go with 5 again. Let's raise it to the fourth power, right? 5 times 5, that'd be 25. 25 times 5 would give you 125, and then 125 times 5, I believe, is 625. So then what would be true here? Couldn't we say that the fifth root, not fifth root, but the fourth root of 625 would be equal to, you got it, 5. Okay, so that's pretty much what they're looking at right here. And here's another thing that they want us to look at. Suppose we're taking an even root. Okay, if that root is even, what they want us to know is that there are two, count them, two real nth roots of b. Think back to when we were looking at, say, this scenario here. Suppose I told you x squared was equal to 36. Wouldn't it be true that there are two answers to the problem? One of the answers would be 6, and then one of the answers would be negative 6. So there'd be two real square roots of 36. However, if I gave you a situation like this, x to the third, and that was equal to a negative 8, there's only one answer to that. In other words, the cube root of negative 8. Because n is odd, there's only going to be one real root for that guy right there. So since we're taking a cube root of negative 8, what number can we multiply by itself 3 times and get negative 8? Well, that would have to be a negative 2. Okay, so what problem number 1 kind of focuses on is just that one fact, is listing all of the real roots. And did you catch that? We said real roots, so guess what's not in the picture here? Yup, no I, no imaginary roots here. The only roots that we're going to be focused on here are the real roots. So let's look at those examples. So in these examples here, what they're asking you to figure out is what are the real nth roots of several particular numbers. In this case, for example, A, they're asking us to look at all the real cube roots of those three numbers there, 0.008, negative 1000, and 1 out of 27. So treat this just as one number at a time. So the first step right there, let's just figure out what the cube root of .008 is. What they want us to try and piece together from this bit of information right here is because we're doing a cube root 3, odd number, only one answer. Okay, so there's only one one real root that when you multiply by itself 3 times you get .008, and that would be 0.02. Okay, negative 1,000. What would be the cube root of that guy? Well, the cube root of that guy would be only one answer, and that'd be negative 10, because negative 10 times negative 10 times negative 10, you get the idea, would be negative 1,000. And to make 1/27th, we could do that if we do a third times a third times a third, right? Top times top times top, bottom times bottom times bottom. There's that 1/27th here. Is that the way I would have done these problems? No. When I'm run across these problems and they want me to come up with the real cube roots or fourth roots or fifth roots, guess what I'm going to turn to? I'm going to turn to this little handy dandy guy. Nope, not that robot there. Should be a great movie. But this handy dandy robot right here, which is the graphing calculator. Okay? So if I want to find the cube roots of, what was it, .008, let me just take a look at that again. Yep, .008. Check this out. Just press that math button. And then look at number 4. We have a dedicated button for cube roots. So then 0.008. There's your one answer right there, 0.2. Sweet, right? Awesome. And then if we want to find the cube root, just press second enter because I'm lazy. Instead of hitting the math menu, now we want negative 1,000. So just put a negative 1,000 in there. Boom, there's that one answer. Cube root of 1/27th. So let me go back over here, change this to now 1 divided by 27, delete the rest. Do you notice I don't even need to close the parenthesis to know what we're talking about right there? And how many of us recognize that 0.3 repeating is 1/3, right? And if you didn't, math fraction takes care of that, doesn't it? Okay? So this is exactly what I would be doing here. If I'm looking at that next set of problems right there, see how they're asking us now for the fourth roots of 1 negative, what? That's negative 10/100ths, thousandths, 10,000ths, and then 16 out of 81. So fourth roots, if you want to do fourth roots, you're looking for a number that when you multiply it by itself 4 times, you get that answer. So the first one really doesn't require a whole lot of thought, right? Can you come up with a number that when you multiply it by itself 4 times you get 1? Well, of course it's 1. So 1 is the real fourth root of 1. But here is where they want you to think about this, because we are taking a fourth root, in other words, an even number, there has to be 2 roots. Okay? So not only is 1 a fourth root, as you see right there, but negative 1 is a fourth root as well. So the correct answer that you'd have to state right here for the fourth roots of 1 would have to be plus and minus 1 is what I'd expect you to write right there for that kind of problem. And we'll see an example a little bit later. Now what about the fourth roots of negative .0001, 1/10,000th? Well, last time I checked, when you take a square root or a fourth root or any type of a root, even root anyway, of a negative number, there is no real root, right? Isn't that what they're trying to tell us right here? If that number, b, is negative, there are no real nth roots, right? That's when I starts to enter into the mix. So do you see, does their answer make sense here? It does to me, right? Because they're taking an even root of a negative number. There are no real fourth roots, okay? Now, here's something that's kind of cool about when you're taking fourth roots or any type of roots of fractions. Here's a cool property. If I was taking the nth root of a divided by b, what is always true is I can take then the nth root of a and divide that answer by the nth root of b. In fact, that's exactly what I'm going to do on these problems here. When I'm looking at the fourth roots of 16 out of 81, I pretty much process it just like this. See that nth root of a over b, think of it like this. And then if I'm taking the fourth root of 16 out of 81, I can say that that's definitely equivalent to this. And then I think you know what I'm going to be doing next. I'm just going to be taking the fourth root of 16. Can I think of a number that when I multiply by itself 4 times and I get 16? Well, wouldn't that answer be a 2? And then do the same thing down below. I think 3 times 3 times 3 times 3 would give us 81. But then don't forget, because we're taking an even root, there are two answers here. So positive and negative 2/3. So that's why we need both of those two guys right there, right? Right, right. So let's take a look at these last problems down here, and then we'll finish up this video. So here's what I'd like us to do. Can you tell me what the fifth roots of 0, -1, and 32 are? So those are three separate problems. Try not to think of this as just one problem. These are three problems in part A. Okay, so give yourself a couple of minutes to do that. Do the same thing with B. We're going to tackle C together. So if you wouldn't mind pausing the video, give yourself a little bit of time, tinker with that calculator there, and write down the answer for each one of these. What would be the fifth roots of 0? And then what would be the fifth roots of -1 would be the fifth roots of 32. Likewise, tell me what the square roots of 0.01, square roots of -1, square root of 36 over 121. Okay? Give yourself a couple seconds to work that out. And then when everyone's ready, let's go ahead and resume that video. Alright, so let's see how we did. Let's check our answers here. So for the real fifth roots of 0, realize what we're actually doing here is just taking the fifth root of 0. Can you think of a number that when you multiply by itself 5 times you end up with 0? Shouldn't take too long. Should be 0, right? So the real fifth roots of 0 should be 0. Is 0 the only answer? Yes. Why is 0 the only answer? Isn't it because we're taking a fifth root, and if 5 is an odd number, there's only one real root, right? So how about the fifth root of -1? Don't be so quick to say that there is no answer, because there is an answer, right? I can multiply an odd number of times and end up with an odd answer like -1, and the correct answer would be -1. Okay, so there is a fifth root of -1, and it is -1. Is there a fifth root of 32? Yep, if you did everything right there, it should be the deuce. Okay, now how about the real square roots? So a square root of 0.01, remember, because it's a square root, how many answers do we need? There are two real answers, so our two real answers should be plus and minus 0.1. What's the real square root of -1? Ha, gotcha. Or did I get you? Maybe you already knew that. There are no real square roots, right? It's all imaginary. And then the square root of all the real square roots of 36 over 121. What I would do there is just take the square root of the top, square root of the bottom. So we'd have plus minus 6 out of 11. Now let's look at this last group here together. Let's explain why a negative real number b has no real nth roots if n is even. So what are they talking about when they're talking about b? They're talking about this number right there, b. So if we're talking about that b right there, if that number is negative, why does it not have any roots if n is even? Pretty much what they want us to think about is that bottom bullet right there. So why is it when b is negative there's no real roots? Well, quite simply put, if we put an even number of identical factors and multiply them together, the answer is always going to be positive. It's never going to be negative, right? Think about it. You put an even list of negative numbers together and multiply them all together. I don't care what number you give me, you're always going to end up with a positive answer and never a negative answer. Okay? So that's pretty much it for problem number 1. The next video in the playlist will get you to practice problem 2.